Hi, this is Jacob's Algebra, Chapter 10, Lesson 1. This lesson is about factoring prime numbers and composite numbers. So a prime number is going to be any integer greater than 1 that cannot be written as the product of two smaller positive integers. A composite number, and I'll write out composite. Whoops. That's supposed to be an E at the end there. A composite number is an integer greater than 1 that can be written as the product of two smaller positive integers. So 1 is not prime or composite. 0 is not prime or composite. Those are just special cases. So prime and composite numbers have to be bigger than 1 and they have to be integers. Okay, so the first thing we're going to work on is factoring. So as an example, if we wanted to factor 924 and we wanted to factor that as prime numbers, looking at this, you can automatically tell that 2 goes into this because it's an even number. So I'm going to break it down into 2 times 462. Okay, looking at 462, again, that's an even number, so we can break that down. 2 into 231. Okay, 231 is not an even number, so we can't divide that by 2. But if we add up the digits, 2 plus 3 plus 1 is 6. That is a multiple of 3. If the digits add to a multiple of 3, then it is divisible by 3. So this number can be divided by 3. 3 goes into 231 77 times. Well, 77 is not even, so it can't be divided by 2. 7 and 7 adds up to 14, which is not a multiple of 3, so we can't divide it by 3. It's not a multiple of 5 because it doesn't end in a 5 or a 0. The next prime number is 7, and you can tell 7 does go into 77. 7 goes into 77 11 times. And now we have broken it down into its prime factors. So how we would write this down is 924 is equal to 2 squared, because we have 2 and a 2, times 3 times 7 times 11. The general rule here when you're writing out the prime factorization of a number is that you write the numbers in order, the factors in numerical order. And if a factor occurs more than once, you write down the power. So instead of writing out 2 times 2 times 3 times 7 times 11, you would write it as 2 squared times 3 times 7 times 11, as I did here. The other concept in this lesson is greatest common factor, which is abbreviated GCF. And this is the largest integer that is a factor of all the numbers that you're given. If, for example, you're given 30 and 75. Well, looking at these, I can see automatically that both of these can be divided by 5. So 30 is 5 times 6, and 75 is 5 times 1, and that's 25. 5 times 15. So we can see that both of them can have a factor of 5. But is that the greatest common factor? So we have to look at what's left here. 6 can be broken down. We can break 6 down into 2 times 3. 15 can be broken down into 3 times 5. Well, you see here we have a 3 in both of these. That means that 5 and 3 are both common factors for both numbers. So 5 times 3 is our greatest common factor, and that is 15. So 15 is our greatest common factor. Okay, real quick before we start working on through some of these example problems, divisibility rules. For a number to be divisible by 2, it needs to be even. That means it needs to end with a 0, 2, 4, 6, or 8. 0, 2, 4, 6, or 8. For a number to be divisible by 3, the digits need to add up to a multiple of 3. Digits add to, I'm going to write just mult of 3. For a number to be divisible by 4, well, obviously it has to be even. But then when you divide it by 2, you have to be able to divide it by 2 again. I'm actually going to write down the rules only for the prime numbers. So 2 is our first prime number, 3 is our next prime number. The next prime number is 5. If a number is divisible by 5, then it will end with either a 5 or a 0. And then there isn't a rule for 7. So those are the only ones that we have some real good rules on. 9 is not a prime number, but 9 does have a handy rule. If a number is divisible by 9, the digits in the number will add up to a multiple of 9. And just as an example, let's take the number 27. If we add the digits together, that's 2 plus 7 equals 9. That is a multiple of 9, so that means it's divisible by 9. It's also a multiple of 3, so it is a divisible by 3. If we had the number 3,462, that number is divisible by 3 because 3 plus 4 plus 6 plus 2 is 15. Now it is not divisible by 9. But if we had the number 3459, then 3 plus 4 is 7, plus 5 is 12, plus 9 is going to give us 21. Oh, wait, that's still not divisible by 9. Okay, so that one is still divisible by 3, not divisible by 9. So to get one that's divisible by 9, you have to, like, 3, 4, 6, 5. That one adds up to 18. That one is divisible by 9 because it has the digits add up to a multiple of 9. Because 3 plus 4 is 7, plus 3 is 13, plus 5 is 18. So just some basic divisibility rules, which will make some of these problems easier. So now looking at the first problem in set 2, that's number 4. Number 4 is just like the homework problem, number 9. And basically what you do is it gives you a list of integers from 11 to 20. Each of the numbers has been labeled prime or written as the product of primes. And so it does that for 11 through 20, and it says make a similar list for the digits from 21 to 30. Well, okay, so 21, is that a prime number? No, because 2 plus 1 is 3. That means it is divisible by 3. 3 times 7 is the prime factorization. 22, that's not prime either. You can tell it's an even number. So that is 2 times 11. 23, that one is indeed prime. 24, well, you can see that this is an even number, so it's divisible by 2. When we divide it by 2, there's 12. Well, 12 is divisible by 2. Really, we would write it out as 2 times 2 times 2 times 3. 2, 4, 8, and then times 3 is 24. So we would write this as 2 cubed times 3. So I'm just going to write 24 again there. 25 is not prime. It is 5 times 5, which is 5 squared. 26 is 2 times 13. 27 is 3 times 9. And 9 is just 3 squared, so that means it is actually 3 cubed, because 3 times 3 squared is 3 cubed. 28, that is 2 times 2 times 7, which is 2 squared times 7. 29 is actually a prime number. And then 30 is 3 times 10, which is 2 times 3 times 5. So that's how you work out number 4, which is just like number 9 in the homework. In number 9, you have to do this same thing for the numbers 41 to 50. So if it's a prime number, you write prime. If it isn't a prime, you need to break it down into its prime factors. Okay, the next problem we're going to look at is number 5, which says factor each of the following numbers into primes. List the prime factors in order from smallest to largest, using exponents where possible. Okay, remember number 5 is going to be just like number 10 that I assigned for homework. So for number 5, we're going to start off with part A. looking at 100. And I like doing these with a factor tree. 100, everybody usually sees this and immediately thinks of 10 times 10. Well, 10 breaks down into 2 times 5, and the other 10 will break down into 2 times 5. I like to circle once I get to my prime factors because then I know I can't break those down any further. So 100 written in prime factors is going to be 2 squared times 5 squared, because you can see I have 2 of the 2's and I have 2 of the 5's all multiplied by each other. Okay, the next one we're going to look at is 5D, which is 2,310. And looking at this, what I immediately think of is 10 times 231. Well, we already know 10 can be broken down into 2 times 5, and those are both prime numbers, so I'm going to circle them. 231 we have come across before. This is a multiple of 3 because 2 plus 3 plus 1 is 6. So I can divide 3 into that. When I divide 3 into 231, I get 77. Well, 3 is a prime factor, so I'm going to break that. I'm going to circle that because we can't break it down any further. 77 we can break down into 7 times 11, and those are both prime factors, so I'm going to circle those. So 2,310 is 2 times 3 times 5 times 7 times 11. We want to write these in numerical order, and if we have the same factor show up more than once, we need to indicate that with a square or a cube or a fourth power, whatever number indicates how many times that shows up as a factor. Okay, I want to do 2 more parts from number 5. Let's look at 5G, which is 15 squared. Okay, well 15 squared, that's 15 times 15. 15 times 15. And we can break 15 down into 3 times 5. So we can do that for both of these. So 3 and 5 are both prime numbers. So what we see here, 15 squared, is actually 3 squared times 5 squared. Another way we could have looked at this was to say, oh, we have 15 squared. Well, 15 is the same as 3 times 5, and then we squared it. When we have something inside of a parentheses that we square, we can, and everything inside is multiplied, we can just square the individual terms. 3 squared times 5 squared. This does not work if we're adding them. This only works if we're multiplying them. Okay, the last thing I'm going to look at from number 5 is part I. Part I is 2 cubed times 14 cubed. Well, 2 is a prime number already, so we can't break down 2 cubed at all. But 14 is not prime. 14 is, whoops, that's a 3. 14 is actually 2 times 7, and then we're cubing that. So I'm going to write this as 2 cubed times 2 cubed times 7 cubed. We have 2 to the third times 2 to the third. That means we have 2 to the sixth times 7 cubed. And that's how we break down 2 cubed times 14 cubed. So that was number 5, which is just like number 10 that I assigned for homework. So we're probably only going to have time to look at one more. We're going to look at number 6. Number 6, if an integer is a factor of a number, if and only if it can be divided into the number, leaving 0 as the remainder. So part A asks, is 5 a factor of 775? Well, that's really easy to tell because we have divisibility rules for 5. If it ends with a 0 or a 5, then it is divisible by 5. This ends with a 5, so our answer is yes. The next one we want to look at is B. Is 3 a factor of 2001? Well, our divisibility rule for 3 says that we add all the digits together. So 2 plus 0 plus 0 plus 1 is equal to 3. And since 3 is a multiple of 3, that means that yes, this number is divisible by 3. And that's as far as I'm going to go on this because the video is about to cut out. We will do a couple more examples from number 6 when we come back in the next video. Remember that number 6 is just like number 11 in the homework.